All right, so we are going to be discussing the last section now of chapter 5 that we are going to do in this chapter. So we're talking about relationships in triangles across the entire chapter, and inequalities in two triangles is what we're focusing on in 5.6. We talked about inequalities in one triangle when we talked about our side lengths and how they compare to the angle measures, that the biggest side is across from the largest angle, the smallest side is across from the smallest angle in one particular triangle. But we're going to also talk about how we compare two triangles together here in 5.6. So the theorem that is going to be discussed here is called the hinge theorem. And if you can kind of think of a door with a hinge on it, and then the two sides kind of moving, actually with a door, typically you have just the door that's moving, and then the other part of the hinge is kind of stationary, like a covered door. But if you have both doors kind of moving, they can kind of swing back and forth. Both of these can swing back and forth, creating some different angles. And so that's what we're referring to when we're referring to a hinge. So that's what a hinge would be, is essentially a vertex here with two sides that can be swinging back and forth. So going this way or that way, and this side goes this way or that way. And so the hinge would be right there. And so when we're talking about hinges in this section, we're talking about where the angle is, where the vertex of the angle where the two congruent sides meet. So you notice the congruent markings here create this angle of 43 degrees and then 30 degrees. Although the side here, notice that in both of those triangles, we have a side situation, but the angle that is included between those sides is different, 43 degrees versus 30 degrees. So in situations, if two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than the included angle of the second triangle, then the third side of the first triangle is larger than or longer than. Almost looks like longer or larger with my handwriting there. I apologize for that. The third side of the second triangle. So if we look at the example here, we notice that both of these triangles share a side with an included hinge. A is the hinge here, and we have F is the hinge here. But the angle 43 is greater than this angle of 30, which means that the side opposite that, in this case BC, is going to be greater than the side opposite the hinge in this one, which is GH. So BC is greater than GH. Hopefully that makes some logical sense there. If the angle is smaller, it's going to create a smaller side length here. If the angle is larger, it's going to create a larger side length. But what we need to have true is that these two pieces have to be congruent to each other, because that would impact the length of the other side. If we didn't have these two sides congruent in both triangles, then we wouldn't be able to make that same conclusion. All right, so the converse of that is also going to be true. We talked about the converses throughout the first number of the units here. Recall that most of our theorems are conditional statements, in other words, if-then statements. And a converse means we're going to flip-flop, reverse the if and then parts of the original statement and see if that is also going to be true. So the first one, if we're going to reverse that, we're going to talk about the side and then relate it back to the angle. So that's what we're talking about in the second one here. If two sides of a triangle are congruent to two sides of another triangle, and the third side in the first is longer than the third side in the second. So here's that converse part. We're talking about that third side now. So notice here we have 8 versus 12. And again, we're talking about a hinge here. So the hinge is at L and at R. We've got congruent parts here. So here's our side. So what we're saying is that notice that this side here, 12, is longer than 8. That means that the included angle measure measure of the first triangle is greater than the included angle of the second triangle. So we still have that hinge with a side, the included angle here. Notice that 12 is bigger than 8, which means that angle R has to be greater than angle L. So just reverse of what we're talking about here. Here we're talking about the sides and relating it back to the angle. The original statement talked about the angle and relating it to the sides. But in both cases, we need that hinge where we have a side-side congruence sort of situation at both parts of the hinge. So let's just talk about a couple more examples. So notice these two triangles are connected together. We have congruent markings, and we know they both share side ZX by our reflexive property. So we're relating then, question is, how does WX compare to XY? And so since we have that hinge here and a side-side congruence, that means that we can relate those two sides and say, well, since the 55 is bigger than 51, the angle or the side opposite that, XY, would have to be greater than side WX or XW. Okay. All we have for that one. All right, in this one, we are talking about the measure of FCD. So F to C to D is the first hinge here. And then, let's use a different color. Our second angle here is the measure of BFC. So B to F to C is that angle right there. Notice that both of the triangles share side FC. And so we also have these other congruent markings here and here. So the hinge is at F on the purple one here, and the hinge is at C with our red angle here. So now let's compare the opposite side to C, to FCD right here, is 3 versus the opposite side to our BFC is 3.6. Since 3.6 is greater than 3, we can say that this angle here, which again is our BFC angle, so angle BFC, this one, has to be greater than our angle over here, which is our FCD, by the hinge theorem, a converse of the hinge theorem in that situation. So let's apply a little bit of algebra to these same situations to make it just a little bit more challenging for us. So once again, notice the arrow here is referring to this right here, this angle, this hinge right here. We have congruent markings here and here. They both share this side. And then the other hinge with our other triangle is right here. That's 65 degrees. Notice we've got 9 and 65. Over here, we've got the 6x plus 15 angle right here compared to the 11. All right, so in this case, what we're asking for is the range of possible values for x, the range of possible values. So we're looking here, we'll notice that we have the size, so we're kind of looking at the converse in this particular situation here. And you notice that 11 is across from the 6x plus 15, 9 is across from the 65. So in terms of the angle, we know that the 6x plus 15, this hinge, that angle has to be greater than the hinge angle over here of 65 because the side opposite that angle is greater. And so our statement would be 6x plus 15 is greater than 65. Right? So let's solve for x in that case. So solving for x, just like an equation, we can solve an inequality by undoing both sides of the inequality and bringing down what's left. We have 6x is greater than 50. And then undoing our multiplication of 6 times x by dividing both sides by 6. We get x is greater than, and this is going to be a little bit of a decimal here, or a fraction, 8.3